guys can still see the analyzer?
Yes, sir.
Okay.
Yes, sir.
Thanks.
All right, so yeah, with the reagent buffer again, we're probably going to say it a lot, but replacing that on a monthly basis is definitely pretty much the most important thing that you'll have to keep in mind in terms of maintenance and keeping it running properly. Again, dumping that solution out is critical, not just refilling the bottle. And you can definitely smell the difference between fresh ammonia and unfresh ammonia. You know, as it ages. Hopefully it doesn't age to the point where it smells like nothing, because that means it's probably been a little bit too long since it changed. But again, when you do that, the fresh stuff is very strong. You do want to do that in either a fume hood or a well-ventilated area outside. It will definitely wake up your senses a little bit, and obviously can, you know, make you a little lightheaded if you don't have good ventilation. And again, filling that bottle about 3/4, 7/8 of the way full. You do want to leave a little bit of space at the top of the bottle, just again because we're using the vapor, and you want to make sure that vapor can kind of have a place to build up its vapor pressure so that it drains into the sample properly. Kind of last thing for setup, you know, installing your probes. Again, what we talked about, simply loosening this nut, finger tightening. Removing your probe. Again, it connects to the cable just by a quick screw turn, quick screw, and then pops out. Again, just insert that cable back in place, and then screw the cap back on. And again, obviously being careful because they can break if you just drop them into the flow cell too aggressively. And again, when it comes to placing those probes, the measuring probe just off the bottom of the flow cell. Really, just you don't want to block the flow path of the sample through the flow cell. You would start to get a little bit of overflow coming out this top side. And obviously, if it's not flowing properly, you're not going to get a good reading. With the reference electrode side, again, the electrode goes in the same way. We do have this added reservoir bottle. Again, filled with solution. It might be a little hard to see on the camera, but there is kind of two tubes. There's an inner tube and an outer tube. There, you can see it now. And that inner tube just kind of keeps a good vent going so that your solution flows properly. If you are in a situation where it's been about 6 months and that bottle is still pretty full, you would want to go ahead and replace it anyway, and take a look at why maybe that solution isn't draining through the electrode properly. Because again, as the sample flows past, the solution inside the reference electrode kind of leaches through the ceramic tip of the probe. And one issue that can happen is as that solution dries out, if you spill a little bit, you'll see it happen quickly, is you get a white precipitate, and just if that precipitate starts to form inside that tubing or inside the actual electrode itself, it'll definitely affect how well it can flow into your sample and you know, perform its job. And you'd want to flush that out and replace that solution.
I just want to mention too with the reference probe, you know, you've got the piece of tube that comes off of the bottle and it slides onto that side arm. When you get replacement KCL bottles, typically you'll see all the pieces of tube that come with it. I don't recommend changing the tube on a regular basis.
This is what your kit would look like.
Unless you have an actual problem with it, because what happens is that larger diameter tube basically seats itself on that little sidearm, and that sidearm piece of glass is very thin, and you will snap that sidearm off if you're not careful. So I typically don't change that out unless there's a problem, or unless you've got a lot of crystallization on the inside of that tube. Then at that point I would want to put a new tube in. And chances are, once you get this in order to break the seal on that little sidearm, you probably need like a real thin flathead screwdriver, and then obviously just very carefully go, you know, completely around that sidearm just to sort of break it free, and then almost, you know, sort of lightly, you know, turn, you know, back and forth, lefty, loosey, righty, tighty type of deal until it breaks free. But I can't stress enough that is a very thin piece of glass and is very easy to break.
Yeah, absolutely. Again, don't need to replace it unless, again, you start to see cloudiness or any of that white crystals start to form. And again, should last you about 3 months, quarterly replacements, but again, if it's been more than 6 months, definitely would want to replace it, regardless kind of how full that bottle is, and again, would want to flush out that electrode, probably with some DI water to make sure it's, that solution can flow freely. So those are kind of your big startup things, which you have to do, especially if the analyzers, again, start up for the first time. And again, obviously the replacements of those chemicals as you go through operation. Is what we'll do now is I'm going to come up to our screen and I'm going to start a 2-point cal, and we can kind of watch what happens. You can see our screen a little bit better than that. Just going to try to start a cal. So we'll press our commands button and hit our 2-point cal button. And you'll hear a click, a little hard to see, I apologize. One thing actually that I didn't mention yet when we're looking at that command screen is that there's no like start button basically. So this analyzer is in continuous operation, so once it's powered on, it kind of assumes that you're online, you're running, and the analyzer is in normal operation. So again, that abort operation button isn't going to do anything unless you're in a cal or grab sample state. What we can see now is that I started the calibration, our first valve opened up, and the screen during calibration will kind of show about what reading it thinks it is. So we're going to come up to, it's reading about 89 right now. Depending on the last cal, that may or may not be, may not be close to 100. If your last cal was a long time ago or it's getting started for the first time, that number could certainly be wildly different from 100. What's important to note is that when it does... What's that?
Hey Keith,
Yeah.
you got kind of a glare on that screen. It's hard to see it. There's a light.
Yeah.
That's
Really
better.
trying. Is that a little better?
Is that better, guys? It's better. It's still got a glare, but we can see it better when we do it a minute ago.
Okay.
I was shining down on the analyzer. Change the angle of the camera.
Yeah, the angle of the camera probably.
That's no way.
That's worse.
Yeah, this was part of the challenge that we had
That's low.
yesterday. That's probably a little better.
Yeah.
Just trying to get the lighting.
That's better.
A little better, right?
That's better.
Yeah, so like I was saying, the analyzer is always kind of online, always running. Once you hit that cal button, it will hold the 4 to 20 output, so you won't see your calibration standards come through on your DCS. And like Joe was talking about, you have that hold period at the end of the calibration as well to allow your analyzer to rinse back down from that high standard before kind of making that 4 to 20 live again. Now that we've got the screen in good view, we're going to shift away from that, of course. What I kind of want to zoom in a little bit is our flow cell now that we have some standard flowing through. And hopefully you can see now that we got some bubbling. And this is what we were talking about, kind of being your biggest indication that things are working correctly. It means you have good flow. It means you have good vapor from your reagent bubbling through. It is important to note that even if the tubing to the buffer was just disconnected and open to air, you would also get bubbling, but obviously it wouldn't be appropriate bubbling. But as long as that tube is connected to your vapor, it means pulling in your ammonia vapor and buffering your sample. So one thing why that vapor is important is principle of operation wise. This analyzer acts a lot like a pH analyzer. So we've got our 2 electrodes looking for electrical potential in the sample just related to sodium. So there's a few things that can interfere with that reading. The probe is, the membrane of that glass is ion specific to sodium. So the only ion that it should let through is a sodium ion. The only ion really smaller than a sodium ion is your H+ ion. So obviously that one can interfere with our reading, the one that can kind of get through that membrane. So that's the main reason for this buffering, is to raise the pH, get rid of any interference from our H+, that might exist. And if you were to check the pH of the sample coming out of that flow cell, we'd be looking for about an 11. Once we get up to that point, we've kind of negated any interference from the H+, and we should be able to get a good sodium reading. The other thing with interference is this earthing tube serves a purpose, being metal and being grounded. Is any static charge that might build up as our sample's flowing through the tubing and the components and things like that will get grounded out, and that'll make sure that that doesn't interfere with our electrical signal at all going from our electrodes. Just because it is a sensitive signal, obviously, and we're looking at such a small amount of sodium that doesn't take much to cause an interference. But back to this bubbling, I mean, this flow is a big part of the operation of the analyzer. And one thing you notice if we go back and look at kind of the whole system architecture, we touched on the constant head block up here. Once our sample comes past this constant head block, all the flow is basically just gravity fed. So it's going to flow through. There's really no back pressure behind the system. And what that does is it helps for a very constant flow, hence the term constant head. But also, if there is a problem with flow, blockage in the tubing or something like that, you'll see it at the flow cell with this, bubbling will slow down. You won't see much sample going through there. And again, the biggest chance for a blockage would just be in this piece of tubing here into our entrainment, just by the nature of it being the thinnest piece of tubing on the system. Again, most times with pretty ultra pure water, that's not too much of an issue, but every once in a while you get some debris that can come through and get stuck and needs to be flushed out. So in terms of our calibration here, as we're going through this, I'm going to get a good view of our screen here real quick. Yeah, nothing. Yes.
Can y'all turn the light off anywhere? Maybe that'll help.
Yeah, we've tried a couple, for whatever reason, this is the most challenging part of this for us, is trying to get this. Yeah. What if I try using my cell phone more?
Might be a better way.
Yeah, this has been the biggest challenge. There you go.
That's kind of what I was hoping to see. All right, so we can start to see now this graph a little bit, which is just giving you a live reading kind of and a plot of our sensor value, which is changing a little bit here. So that sensor value is just our live reading of what the electrodes are putting out. And it's not really too helpful to see, other than that, again, when we go for a calibration, we're looking for the difference between the two standards. So we're not necessarily looking for a certain number on that millivolts, but we're looking for this change, this step change here. There we go, see it a little bit now. And that step change, again, was the number that Joe was talking about 60 millivolts difference. So again, the number where it starts and where it ends is not as critical as seeing the change between the two. So when it runs its calibration, the number that it's basically going to calculate is this strength or slope value that we've talked about. And that's kind of the determination of whether we get a failure or a passing cal. And what it's looking for, it's basically comparing to a theoretical perfect slope. Say, hey, if everything's right, you get 100%, and that'd be basically lining up with a perfect theoretical curve. Outside of that range that we have preset of 83 and 110, this just says, hey, we're far enough away from a theoretical passing calibration that something's probably not right. So again, with the calibration, it's all timing based. So it's not looking for a certain number. It's saying, hey, analyzer, you have 10 minutes, 15 minutes to give me the number, the response that we need. So one of the reasons for that is as our electrodes age, the response time tends to be the first thing that kind of indicates that they're kind of starting to fail. So if you have a calibration that might pass if you let it sit there for an hour in standard, that's not going to be very helpful if you start to see a high sodium event or something like that. It's kind of going to defeat the purpose of having the analyzer if you have a slow response. So again, it's kind of based on time. It's not looking for a certain number. If you do fail calibration, the analyzer will go back online using the last good cal factor or good cal slope. So that just means that if you failed cal because say you were at a calibration standard, your number is probably pretty accurate still, but you cannot clear the cal failure alarm without passing a calibration. So you can't just continue to fail calibration, go to the screen, hit, okay, I saw it, and then continue on your way. You do have to pass the cal to get that alarm to go away. But again, you still will go back to reading online with probably fairly good results, again, if it was just something due to lack of calibration standard. If the analyzer passes calibration, especially the auto cal, if you have it set for midnight on a Tuesday, it'll kick onto its auto cal, it'll go through its calibration, go back online. Again, if it passes, you probably won't even notice that it went through its calibration. It'll be back online again and kind of keep going through it. Again, if it fails, it'll go back online, but it will give you that failure message just to know, hey, something's not totally right. So again, with the cal fail, if it fails and we're on the low side of that slope, like less than 83, typically that means our response is not enough. And usually that's a measuring electrode issue. One thing we talked about in the maintenance before was this regen solution. It's kind of an acid solution. Again, it kind of etches away the top layer of glass and opens up the membranes of that probe again. So as our electrode ages, that can certainly help, help bring the electrode back to life, and then we can recal and hopefully get passing calibration. Typically, if we fail on the high side above 110, usually that's a reference electrode issue. And a lot of times it's just the standard, or that solution, that KCl solution inside the electrode, that's either not flowing properly through the electrode tip, or again, most of the time the reference electrode issue has to do with that solution. And you can empty the solution out of that probe, flush the whole probe out with DI water, and then rinse it back out with KCl solution, put it back in service. And about 9 times out of 10, your reference electrode will be back to good after flushing out that solution. Again, those are kind of the two biggest, kind of the first things to look for with your slope. Obviously, if you get a slope of 0 or something like that, probably means you're out of standards. It's seeing kind of the same standard for both solutions. So it could be a solenoid failure or something like that. The other thing with the calibration that's good to mention is not only obviously are we calibrating the analyzer for results, but we're also giving the probes a chance to see a high sodium standard. It kind of wakes the probe back up. So again, if we were to sit just reading DI water real close to 0 for weeks and months at a time, that will certainly slow the response to the electrode. And then when it sees a higher sodium concentration, it will be very slow to respond. So kind of the one reason we wouldn't want to go much farther than a month between calibrations is we just won't see the response from the electrode should the need arise to see that. So it kind of wakes it up, and obviously also make sure we're reading accurately, but make sure that everything else is working properly too within the analyzer. Again, should you see a high sodium event on your sample. Any questions about calibration? Any questions about like the components and our flow through the analyzer?
Grinder?
Does your probe have a reference ground?
Yeah, does your probe have a reference ground?
So the probes, yeah, are connected through the cables, and these cables your reference and your measuring probe both have a grounding side and then their kind of their measurement side, and they connect into the preamplifier, which is behind this wet section panel, before it goes to the transmitter, and then it's grounded inside the preamp. Yeah, to ground out the signal between the electrodes.
And once this is done with the calibration, we can sort of spin the analyzer around and we can show you the backside of it so that we can see what we're talking about.
Yeah, actually calibration's finished, it passed. Actually, hold on. Where else?
I'm gonna leave the volume on, basically, at this quick.
So here on the back side, we have this preamp here. This is where our electrodes come in. Again, these are just BNC connections on this end. So should you have to replace the cable, spin it off and go on. Let me take off this back panel here real quick just to show you what's going on behind there. Mostly it's just tubing. All right, so with this panel off, again, mostly it's just tubing, running from the front side of the panel to the back side of the panel just to kind of clean up the front side, makes the back side look a little crazy. The only component back here other than the preamp is this heat exchanger. So we keep talking about heat exchanger. The heat exchanger is not actually doing any heating or cooling. It's really just helping your standards come to an equilibrium temperature with your sample. The analyzer with the thermistor does have temperature compensation built into its calculations, but even with that, when you calibrate with your standards close to the same temperature as your sample, you're just going to get much better results when you go back to reading online. So what this heat exchanger has is kind of 3 plates. So there's a middle plate, and this has our sample running through it, and then the 2 outside plates have each of the calibration standards going through it. So each of those plates kind of have a bunch of grooves cut through with stainless steel plates in between them, which just allows, again, the samples to flow through and kind of come in contact with those stainless steel plates and just allow heat transfer to happen. Again, the heat exchanger is not actually doing any heating or cooling, it's just allowing the samples and the calibration standards to get to be about the same temperature. I think the only other real maintenance thing, we talked about extended shutdown. Tubing replacements, kind of the other thing which we have on the manual is about a year. Again, that can wildly change based on the sample that's coming into the analyzer. If you have real clean, ultra pure water coming through it, you might not have to do it every year. There's other places where we probably have to do it, every couple months because the sample's just that dirty. And again, flow will start to affect how the sample's running through the analyzer and flowing past our electrodes. but the tubing kit that we supply has all the tubings kind of pre-cut, so it's just taking them off one by one and putting the replacement tubing back in its place. Yeah, but any questions? I think I've kind of covered most of what I can think of. But if you have any questions, or certainly if you think of any, as we're sitting there in between, the break we take, we can certainly start off with any of that.
Might wanna let them know about the date codes on the drones.
Okay. One thing with the electrodes, we do date code them. So when you get them, it'll have a week and a year. Just so you always know when that probe is kind of manufactured, should line up about when you get it. In terms of probe life, a measuring probe should last about 1 to 2 years, I would say. There's certainly places that want to proactively replace them on a yearly basis, but there's also certainly have probes running for 3 or 4 years, no problems. For me, it's kind of if it's passing calibration, most likely the probe is good, and there's no reason to really have to replace it. That regen process, each time you do it, does kind of decrease the overall life of the electrode. Again, just because we're basically etching off the top layer of glass, you do it too many times, there won't be much glass left. I don't know the number of, I can't say, oh, do 10 times you're gonna be out of glass, but each time you do that, you do slowly decrease the life of the sensor. But again, most of the time with the regen, you probably won't really even have to do it for at least a few months, maybe a year. And then after that, if you start to fail calibrations, occasionally, then once you get to the point where you're failing calibrations on a monthly basis and the regen's not really helping it, that's when you want to replace your electrodes.
And I want to mention too that as part of some of the spare parts that you guys ordered and will be stocking in the warehouse, there is what we call a sodium spare parts kit that you guys have purchased, and that kit has every fitting that goes on the analyzer, and also has a thermistor and a solenoid valve, and each one of those compartments is labeled individually. In an event that you use or consume all those items, then you can just reorder that specific part. But just keep that in mind that if you get a broken fitting or a failed solenoid valve, you don't really have to panic, because you do have that kit, and you'll be able to pull the necessary parts out of that to keep it operational, and then obviously just reorder whatever component it might be, as you see fit. Any other questions on the sodium?
What's the shelf life for the probe?
Not so much a shelf life. We give a 6-month warranty from the date code on it, provided that they're stored, in a controlled environment, dry, cool. You should be okay with it. But to actually give a shelf life, it doesn't really have a specific date. It's when we ship them out that they get the week and the year put on it, and it's just for warranty purposes. In an event that somebody says, hey, I just put a new probe in and it doesn't work, and then you look at the date code and it was 4 years ago. It's like, well, you gotta sort of look at it that way.
Yeah, typically we have those in stock, so we try not to encourage keeping too many on hand. We usually get them out pretty quick. One thing to consider in the cold winter months, we do tend to ship them overnight just so they don't freeze. We won't ship them on like a Friday afternoon, so they sit in a warehouse and potentially freeze over the weekend. But again, we almost always have them in stock so that we can get them out to you quickly should you need them.
Other questions? All right. Well, we got 12:17 here at our time, so why don't we take a 13-minute break and come back at 10:30? and then we'll go from there. And I just want to mention too, we're getting pummeled with this tropical storm today, and we probably should have mentioned it earlier. But in the event that we lose power, get disconnected, you know, we've got some things, some backup stuff that we should be able to get through this. But it's just something to mention if for some reason a feed comes through goofy or something like that. It's you know, we're getting quite a bit of rain, and the wind is supposed to pick up here not too long from now.
All right, sorry about that, guys, wish you all the best.
Yeah, thanks. So we think we'll be okay to get through this, but yeah, we'll get back. We'll jump back here at 10:30. Go through like I said, we've got a silica analyzer, but it's the same thing as your iron and your hardness, and then we should be good to go. And we've also got certificates for everybody from the previous training and this one. They're going out in the mail today, so they're going to Mike's attention. So when they get there, you know, you can just administer them to all the guys that participated.
All right, thank you, sir.
All right, we'll see you guys in about 10-15 minutes.
Sounds great.
Well, and the thing is, oh, should I turn the recording on?
Oh, yeah,
So just,
yeah, just like that. Just gotta, it's basically set up like a second screen.
I'll just pause it or stop it.
Yeah, just stop